Hello everyone, very good day. My name is Denny. I'm from Java Offshore. Thank you for the introduction just now. It's a good one, I may say. This afternoon, I'm going to talk about one of the consulting job we did in 2019. About 2 years ago, one of our client contacted us and the plan to have a drilling campaign in their wellhead platform as part of their drilling development program. They seek our assistance in getting location approval for the rig entry into the site. It is not a normal rig entry approval procedure, as the rig will be reinstalled adjacent to wellhead platform that already in a production phase. Furthermore, there are many craters and footprint at the seabed in the vicinity of the platform. Before we talk about the case study itself, it will be good if we see a brief history about the site development for a better visualization. The platform was installed in 2014 and designed to have a 9 well, as shown here. Right after commissioning of the platform, the first drilling campaign was carried out in 2015 to drill the first of 4 wells. The Jacob was positioned in this location with the rig heading was in the platform north direction. The maximum spud can penetration at the time ranged between 16.5 and 17.3 meter below the seabed. Um, 2 years later, the second drilling campaign was carried out in 2017 to drill the remaining 5 wells using the same jackup rig and deploy at the same location as the previous campaigns. So in this case, all the three spud cans were installed right at the existing of the footprint. The final penetration range from 20.1 to 21.5 meter below the seabed, about 3 to 4 meter deeper than previous campaigns, even though installed using about the same maximum preload. So this is the bathymetry contour after the first two drilling campaigns. Uh, Three obvious craters among a few minor ones from the soft pin of the Jacob is clearly seen here. Okay, let's see in the full screen for a better presentation. All right, the third drilling campaign was planned in 2019 to drill the additional well, which are basically the extension of the platform, showing in the four pink square here. In order to reach this target well, the Jacob rig must be positioned at least 7 to 8 meters away from the previous Jacob location, meaning that the spud cannot be reinstalled at the location of the existing footprint anymore. So the client used the different Jacob rig, but has the same design and class as the previous one, and we name it as a rig 2 here to differentiate. Yeah, this is a location that and the orientation proposed by the rig operator so that all the well here can be accessed. However, the three spud can will sit partially in the footprint, which can be problematic. Instead of the pure vertical loading as a normal installation, the spud can will subject it to eccentric and incline loading from the combined effect of a seabed depression due to the footprint, as well as from the shear strength variation between the intake soil and the disturbed soil here. The spud can easily slip toward the footprint. Significant horizontal force and bending moment will appear at the footing level and transfer to the leg hull connection. This may break the Jacob rig, and in the worst scenario, the Jacob rig may collide with the platform. The last thing anyone expected to happen. In this situation, avoidance of the footprint is the most effective measure to minimize spud-can footprint interaction. And then if you refer to standard practice, both NAMI and ISO recommend that the safe distance of reinstallation position to minimize the interaction is at least at one spud can diameter clearance between edge of the spud can to the edge of the uh, footprint. So in this case, we have at least two diameter center to center distance. However, avoidance was not always possible due to the location constraint from both east and west side of the platform that currently we deal with. Having discussed with client, rig operator, and MWS to minimize the unavoided spot-can footprint interaction, it was decided the rig should enter the platform in the direction of 64 degree as shown here. The offset distance range from 25.9 meter at the bow leg and to around 20.8 meter at the port leg, and then only 8.6 meter at the starboard leg in order to reach all the four well location here. We perform geotechnical impact analysis for the selected location. The borehole and CPT from our campaign in 2014 is also shown here. So for this study, we have selected four different situations of SPAT-CAN footprint interaction to be presented in this seminar. The first one is a reinstallation of the SPATCAT at the center of the footprint from the first revisit. And the second case is when the offset distance about 1.5 SPATCAN diameter. We need a site-specific analysis here as a distance is shorter than a SNEMI and ISO recommendation of 2 times SPATCAN diameter. The third one is, and the fourth is similar, but with even a shorter distance, only 1.2 and 0.5 here. When the offset distance less than 1, like in the starboard leg here, the SPATCAN will partially sit at the footprint area. Toward the end of the presentation, we will also present the mitigation measure to minimize or eliminate the impact of the interaction into the upcoming Jacob rig installation. And then the objective for this presentation is to share what we observe and what we have learned from these cases. All right, let's see what we can learn from case number one, SPATCAN reinstallation at the center of the existing footprint. From the soil investigation we performed in 2014, the soil condition consists of very soft to soft clay. The first top 8 meter underlain by 3 meter thick of firm clay, and then followed by stiff, firm to stiff clay below, all the way to 50 meter below seabed. During the actual emplacement in 2015, the maximum penetration reached recorded around 16.6 meter. And then during the revisit, the maximum penetration increased to 21.5. From our back analysis, the actual penetration will match well when the soil strength below the previous maximum penetration here is reduced by 10%. This soil softens effect is due to the breakout failure between the SPATCAN base and then the soil during the SPATCAN extraction. And then also the penetration during the live seep weight here is significantly deeper than the previous rig emplacement, as the soil inside the crater basically become a remedial soil or filled by a very soft deposit of 5 to 10 kPa only. And a similar observation and trend we also notice and observe in the other two lakes. So some conclusion that we can draw from case number one as follow. The first one is during the revisit, the maximum penetration will increase on the average about 0.2 diameter of the SPATCAN diameter. This is due to the softening effect of the soil below the SPATCAN from the extraction. And the soil above the previous penetration was left with the extremely soft deposit. We also learned that from our for the analysis strategy analysis, to use a remolded strength above the previous final penetration, and then to reduce the soil strength about 10% below the previous spot can maximum penetration about zero point 0.2 diameter depth, of course within the same soil layer. Let's continue to case number 2, Spatken reinstallation at the center to center distance of 1.5 diameter to the nearest footprint. The analysis can only be modeled appropriately using a 3D model due to the Spatken and footprint geometry. The method we adopt here is to achieve the reasonable good result was using a simplified geotechnical 3D FEM modeling, which is fit for purpose for the current analysis and geometry. When the offset distance about 1.5 diameter, the spatken is also penetrate vertically without obvious sliding and tilting behavior. A minor spatken tilt angle of zero point 0.1 only is observed. And then the factor ground factor movement look symmetrical around the spatken without obvious distortion. The existing footprint is not affect the spatken installation due to the decent effect of 1.5 B. A similar observation found in case number 3. We skip it first for the time being, and we continue with case number 4. Here we have a spatken located too close to the existing footprint, offset only 0.5 diameter, and at least 40% of the spatken will overlap with the existing footprint. The factor of ground movement showing excessive squeezing of the soft deposit inside the crater pushed away by penetrating spatken. This ground movement contour also indicate the same thing as the spot can penetrate under the preload. The existing crater located is just too close to the spot can, and then it will jeopardize the installation of the rig safely. The modeling result indicate under this condition, the spark is expected to tilt excessively toward the existing footprint with a tilt angle of 5.8 degree, which is not acceptable by the rig operator. And then this 5 point degree tilting can cause a huge moment in the connection between Spatken and the leg. And hence, we also discussed the possible mitigation measure and the way forward for the starboard leg installation for the client location approval to the MWS. Various mitigation measures for Spatken footprint interaction can be grouped into location shifting as the first choice here, and then followed by either seabed modification and footing modification. A survey performed by Global Maritime and Fugro in 2003 reported that only 15% were possible to achieve avoidance of the footprint. The next practical measure by performing a seabed modification such as stomping, reaming, soil softening, and infilling. The first option we propose is stomping, basically by making the footprint big enough so that the purpose new spatken will sit within the enlarged crater or disturb soil. We also did the simulation and observed that the spat can penetrate almost vertical after a single stomping. However, rig operator is not in favor of this option as the installation time and procedure will be too long, basically double the reinstallation activities, including the positioning of the rig. The option that finally selected is a leg reaming. Reaming is reported to be effective in firm to stiff clay, provided that the small stroke up and leg up and down movement is adopted. Virgin part of this ground is remolded by moving up Spartan up and down repetitively as shown here, and then at the starboard leg the reaming was performed between 11 to 21 meter at the firm to stiff soil below the previous Spartan penetration. Basically the we are shifting this curve from virgin condition to a remolded one. In addition of to reaming, the rig operator and MWS adjusted the rig heading from 64 to 75 degree, so that all the BL location here has a more offset more than 2D, and while the PL spot can offset about 1.5 to the nearest footprint, and a reaming was performed at the starboard leg prior to preloading into the maximum intended preload. The conclusion that we can draw from case number 2 to case number 4 are as follow. The spatcan will tilt significantly when the center to center distance between the spatcan and footprint is less than 1. In this case, some part of the spatcan is overlapped with the footprint. Based on our experience, not only in this current project, we have a few similar cases before. We can conclude that the beyond 1.5 diameter offset, the spatcan interaction is in fact is negligible and then can be regarded as a safe distance jackup reinstallation location. We also learned that if the spatcan footprint interaction is unavoidable, then it is recommended at least one leg is located at the area of more than 1.5 D offset, while the ground modification is performed in the other leg prior to preloading to the maximum intended preload. So those are basically what I want to share in this occasion. Prior to end my presentation, I would like to thanks to Dr. Bashir for his and his team for arranging this seminar, then to Java Offshore Management for continued support, as well as for Geo Consulting Division of Java Offshore. A little bit introduction about the Geo Consulting. At the beginning, Java Offshore key business segment was a geotechnical survey and geo-investigation, geophysical survey. Later on, we introduced another business segment, geo-consulting, to support our client for specific engineering needs such as geohazard assessment, survey planning, and interpretative studies. We do not want to stop or consider as a data collector only, and then we are keen to leverage our client investment on the survey by offering additional service in geotechnical and geoscience using the data we have collected for them. Geoconsulting itself has 3 units: geodata that handle our factual data from our campaigns, both geophysics and geotechnic. Then there is a geo solution focusing on the problem solving problem geomechanically or through a geoscience approach. And then the third unit is to manage our data in a GIS format, very useful for our operation. Thank you to for Prof. Haritan and Dr. Sen of National University of Singapore, who already assisted us in running the 3D finite element analysis material collected from various sources on the internet, from the client, as well as from in-house training material of Java Offshore. Last but not least, to all ladies and gentlemen who already allocate their time and attention to listen. Thank you.